Hey everyone, and welcome to today's Explainer. We're diving straight into something that is literally rewiring the healthcare industry, Palantir's Foundry Ontology. If you follow clinical informatics, you already know that bridging the gap between raw data and real-time patient care is the ultimate frontier. So let's unpack exactly how this specific architecture is turning that massive ambition into an everyday reality.
Right off the bat, why is healthcare data, arguably the most valuable data in the world, still notoriously trapped in silos? Imagine a critical emergency. A patient hits the ER, but their allergy history is locked up in an isolated local clinic's system. The recent blood work? Stuck in a totally disparate pathology database. And the on-call specialist schedule is floating around in yet another disconnected workforce platform. Forcing clinicians to hunt down this life-saving information across a dozen different systems isn't just an IT headache. It actively delays and hinders patient care at the exact moment when seconds literally mean the difference between life and death.
So to understand how we actually fix this, our explainer today will follow a quick roadmap. 1. The healthcare data problem. 2. What is an ontology? 3. Semantics meets kinetics. 4. Real-world healthcare impact. And 5. Governance and responsible AI.
Starting with Section 1, the healthcare data problem and how we finally escape the silos.
A really common misconception is that modernizing healthcare means we have to dump everything into one giant centralized national data warehouse. But honestly, trying to centralize all that sensitive data creates massive security bottlenecks, and it completely strips local hospitals of their autonomy. Instead, Palantir uses a federated system. You can think of it like a secure network of bridges. Take the NHS Federated Data Platform, for example. It connects existing local hospital environments without taking away their organizational control. The data stays safely tucked away at home in its original environment, but, and here's the kicker, it becomes instantly interoperable and actionable the moment an authorized user needs it.
Moving on to Section 2. What exactly is an ontology? Let's define the abstract.
Okay, think of traditional data systems as a static medical textbook. Sure, it holds vital information, but it doesn't do anything on its own. A doctor can look up a treatment, but that book doesn't know a thing about the actual patient sitting in the room. The Palantir Ontology, on the other hand, is like a living nervous system. It's an active, breathing digital twin of a hospital's entire operation. It sits right on top of all the digital assets, like databases, legacy apps, and machine learning models, and binds them to their real-world counterparts. So a row of data isn't just text anymore. The system inherently understands that it represents a physical hospital bed, a specific high-risk patient, or a live surgery happening right this second.
The leap from merely storing data to actively operationalizing it is absolutely staggering. A static data lake is basically a giant digital filing cabinet. It just documents where things live and looks backward at what already happened. But an active ontology models the incredibly complex, interconnected decision-making of a clinical enterprise in real time. It handles data anomalies on the fly and creates shared live clinical context. This means humans and AI can actually collaborate to make complex, on-the-spot decisions about where to route a patient or how to allocate resources, instead of just pulling a historical report at the end of the month. All right, Section 3, Semantics meets Kinetics, which is really the engine of action here.
Under the hood, the ontology works by marrying semantics with kinetics. Think of semantics as the nouns. It defines the strict structural boundaries of what a patient, a drug, a provider, or a care pathway actually is within the system. Kinetics, those are the verbs. They dictate exactly what actions and workflows can be securely executed with those nouns. It's a massive leap beyond just querying a database, mostly because of governed write-back loops. Every single time a clinician makes a decision, that action feeds directly back into the system. It updates the state of the digital twin instantly, compounding the value of that data for the very next person who uses it.
Now, managing all this architectural complexity requires dynamic translation. Take an OMOP database, which is a common standard used for observational health data. A single row showing a drug exposure in OMOP might need to be translated into the FHIR standard, which is used for real-time data exchange across modern healthcare apps. Depending on the exact clinical context, that one drug exposure could represent a prescription request, a physical administration of the meds, or a historical dispense record. Foundry handles this complexity through pre-configured bidirectional mapping pipelines. It instantly resolves structural differences so that clinical workflows never break when you're moving between different analytical and operational environments. Let's look at Section 4, Real-World Healthcare Impact. How does this actually move from theory to practice? Because this is not just theoretical whiteboard stuff. As clinical informatics leader is discussed at HIMSS, which is the world's premier healthcare tech conference, integrating these fragmented systems is the exact catalyst we need to build tomorrow's health. It's all about turning raw, isolated information into immediate action across massive multi-facility hospital networks. And if you want to understand the sheer scale of this capability, just look at the pandemic response. The National Institutes of Health used the Foundry platform to create the N3C Data Enclave, the National COVID Cohort Collaborative. It became one of the largest secure clinical data repositories on the planet. They rapidly and securely harmonized electronic health records for over 8 million patients. By bringing together massive real-world data from dozens of completely distinct research institutions into one environment, they shattered the traditional silos that slow down medical discovery, drastically accelerating life-saving research when time was quite literally running out.
Over in the UK, the National Health Service uses this exact pipeline to turn fragmented hospital data into reusable tools. First, data originating from entirely different systems is ingested using standardized connectors. Next, it's cleansed and validated to handle any anomalies. Finally, it gets integrated and mapped directly to the ontology layer, strictly aligning with NHS standards. This process completely empowers hospital trusts to move way beyond basic reporting dashboards, allowing them to actively manage patient flow and accurately predict workforce needs in real time.
We're also seeing some incredible translational research happening at the MD Anderson Cancer Center. Clinical researchers there leveraged this ontology architecture to automate the extraction of complex, high-fidelity data directly from preoperative MRI scans for rectal cancer patients. By querying internal records and validating this data at scale, they drastically cut down on manual data entry. That capability freed up countless hours, ultimately accelerating their ability to analyze outcomes and discover new highly targeted treatments so much faster. Finally, Section 5, Governance and Responsible AI. Building trust in the system.
Because the ontology actually acts upon the real world, that's the kinetic side we talked about, strict security controls are non-negotiable. Palantir ensures total visibility through data and workflow lineage. This means an auditor or a clinician can trace exactly how an AI model arrived at a conclusion, step by literal step. Crucially, it mandates human oversight. There are hard-coded checkpoints built right into these operational workflows to ensure AI acts strictly as an assistant. It's there to enhance, never to replace, human clinical judgment. And the whole thing is protected by granular, role-based privacy permissions that restrict data access down to the individual property level. As Palantir's AI platform guidelines state, responsible AI is not an afterthought. Rather, it is fundamental to how we build technology. In healthcare, ethical considerations can't just be a compliance checklist tacked onto the end of development. They have to be deeply integrated into the entire lifecycle of the system to guarantee that these tools deliver reliable, equitable, and highly accountable outcomes for patients.
So, as we evolve from storing data in static lakes to operating inside active, living digital twins, the clinician's role isn't disappearing, it's being supercharged. Which leaves us with a final question to think about. How will you harness this human-AI collaboration driven by a robust clinical ontology to redefine the future of medicine in your own organization? Thank you for exploring the Palantir Foundry Ontology with me today. Keep questioning, keep learning, and I'll see you in the next explainer.